Hello, welcome back to the video lecture series for Introduction to Data Programming using Scala. We continue talking about aliases, and we're going to look at how aliases are significant in function calls. It turns out that every time you call a function, you are making an alias. So this didn't matter so much when we were passing things that were non-mutable, because as we discussed in the last video, things that aren't mutable or that are immutable, you can have an alias to them, but since you can't change it through any of the aliases, it's not a problem. But as soon as you have something like an array, which is mutable, then creating aliases can become significant. Now, in some cases, this is what you want. Consider the function. I'm just going to write a simple little function. I want to take an array. We'll make it an array of ints. I want to take an index, which is an int, and I want to take a value, which is an int. And this is going to be as simple as setting ARR sub index equal value. Okay. So this is a function that is supposed to set one element of an array to a particular value. The fact that it is supposed to change the array actually is hinged upon the idea that we have aliases here. So if I try to call this set in array, and I'm going to pass it ARR3, this array that we had from the previous video, we made it using map, so it is actually a copy, and it has 1, 2, 99, 4, and 98 in it right now. And let's say that I want to change the fourth element to not be 98, but to be 6. Okay. That calls that function. And if we look at ARR3 now, indeed the last element is 6. So what happened in this call? Well, we had this declared inside of there, and when I called the function itself has 3 variables here, and so each of those would get its own box: ARR, index, and value. So ARR, index, I need to make that box a little bigger, and value. Okay, so these are our 3 variables that are declared inside of that function, and what happens with them? Well, the index and value wind up being references to objects with the values of 4 and 6. And we will draw their little arrows in place. This seems simple enough, but the part that really matters is what happens to ARR. ARR, we're passing in ARR3, so ARR is bound to that and becomes a reference for or to this exact same object. And that's essential, because if it didn't point to that same array, if it pointed to some other array, we wouldn't actually have the side effect that we want. We want the fact that this value was set to 6. That is the whole purpose of this function, and that only works because they are aliases to the same object. And so when we change ARR inside of the function here, we're actually changing the value that's stored in the array, even though that array exists outside of the function. For all of the methods that you saw where we passed in arrays and we set all the values to something, or we read things, we were utilizing the fact that all of these, the values in the array are mutable, and the fact that when we pass in the array, we wind up getting an alias to it. And so all the changes that we made inside of there were happening to the original array that had been passed in. let's think of one of those a little bit more closely, of set all to. It's going to look very similar. I'm going to pass an array of int. It takes an index, which is an int, and it takes a value, which is an int, and this one isn't going to return anything, and I want to be explicit about that because it's going to be recursive. If index is less than arr.length, I want to do the following. arr sub index equals value, followed by set all to of arr index plus 1 and value. Okay. And as the name implies, this is supposed to set all the values in the array, technically after whatever index we pass it, to the value that we want. So if I set all to on arr3, I'm going to start at index 0, and I want to set everything in here to 42. When that's done and I look at arr3, I have an array that is full of 42s. What happened in this function call? Well, we started off with this situation. It created arr, it created index, and created value. In this case, index was 0, value was 42, and it checked, is index less than 0, is index less than the array's length, which it was, so it came into here and it set the thing at index to be value. So it did that. And then what was the next thing that happens? It calls itself with index plus 1. Now I'm not going to draw this all out, but at that point we get another stack frame. Okay, we get another set of all three of these variables, arr, index, and value, are created all over again. Okay. So I could, if I wanted, make this a little bit smaller and copy these, paste them over here. We have another set. Instead of pointing to 0 and 42, they point to 1 and 42. We can actually think of that as going to there, but index points to a new object over here that stores a 1 inside of it. Oops. And this arr, like the one before it, also is an alias for the thing that was passed in originally. And then the function gets called again and again, and every time it gets a new set of these three variables. When the function returns, those variables cease to exist. So after it had gone through this last one, it then pops back and three variables pop off the call stack. They cease to exist. And then three more variables cease to exist, and three more variables cease to exist. Notice, they're always the same names, but they are not the same variable. Okay? Every time that we call a function, we get a new set of these variables, and they just happen to have the same name. I like to tell my students, it's like knowing two people named Bob. Doesn't mean they're the same person just because they have the same name. Just because we have two variables named arr does not mean that they are the same array. In this case, they do wind up all being aliases to the same array, but they are different references that point to the same object. So, the key point here, every time you write a function and you call it, you are making aliases to the objects that you pass in. And if those objects happen to be mutable, that means that the function you pass them to has the ability to change them. In next video, we'll come back and talk a little bit about how this isn't quite the right image of what an array is. We'll talk about exactly how you should view the array instead in your head, even if you aren't always willing